Hello and good evening. Uh, I will I will do the introduction for our team. My name is Syed Ahmadi bin Syed Kamuddin and my team is Ahmad Syakirin bin Ahmad Syauqi, Muhammad Lumar Hakim bin Zamran and Muhammad Nazir Arif bin Muhammad Zaid. This is our project for electronic communication system. So our project do is the bandpass filter circuit or device that's only allow predefined set of frequency to pass through it. There are two types of bandpass filter, that's the high pass and low pass. For the high pass, they only allow the higher frequency to pass through it, and the others low pass is only allow lower frequency to pass through it. If the external source of the power involved in the transistor, the pass will be called active bypass bandpass. If the current did not involve any active component, the uh, and consists only passive component like resistor, it calls passive bypass. So this is the formula for the bandpass circuit. The Fc high equals to 1 over 2 pi R1 C1 and Fc low 1 over 2 pi R2 C2 and bandwidth equals to Fc high minus Fc low. Next is methodology. For this project, we are given to choose between two different projects. So the one we choose is bandpass filter. So in the planning, we do the data collection to find all the questions that need to be answered. Next, we do the circuit design with description and the formulas or for the calculation can be found on the internet. Next we do is the step is implementation. For implementation, the design and simulation of the bandpass filter are carried using multisim. The final step is evaluation. The circuit is investigated based on the simulation result. Thank you. And finally, this is our bandpass filter circuit that we choose. Thank you. I will pass this presentation to Luqman.
Assalamualaikum. My name is Muhammad Makim Zamban. My number mate is CN200-147. Today I will present my part, which is circuit simulation. We can say our circuit, which is have two operational amplifier, one voltage source, resistor and capacitor. At first, if we want to show the input signal, we must use the oscilloscope, and then which is the A positive, we put it in there, and then the A negative, which is we put it at the ground, at the output VO. And after that, we run the circuit, we run the simulation, and we can see the signal, the input signal. Okay, and for this graph, for this signal, we can change that. We can want the white or white background or black background. After that, we can setting to like this. We can setting our graph like I do right now. Yeah, wait, setting. And then we was going to 500 US, and then change to 500 MV, and then we can because we use the SC voltage source, we must put to the SC. This one is the SC and single, and then we can put it to here at the negative side and to the positive side, and then we can see our input signal and our time and our voltage. And after that, we can use this to find the highest Y max, like this. After that, we continue if you want to find the output for the bandpass, and we use the baud filter, which is in positive we put it in here, and the out negative we put it in here, out positive we put in here, and then in negative and out negative we put in at the ground. And after that we run the simulation, and we can see our graph, which is here. And then if we want to setting like the cut like more accurate our graph like this, we can do like this if you guys want to see it. Okay, and then we put it in here, and we can see our graph, which is for the 3000 here. So thank you for the
Alright, so this is the result and discussion for our project, which is in sinusoidal waveform. So figure 1 shows a sinusoidal waveform generated by the power supply's alternating current AC. The waveform amplitude is set to 1 volt for the voltage peak and 1 kHz for the frequency value. Depending on the positive and negative maximum values of the half cycle, alternate waveforms continually change their polarity. Alright, so in the left side, waveform cutoff frequency low, we get the FC low is equal to 0.32 kHz. And then on the right side is waveform cutoff frequency high, FC high is equal to 0.4 kHz. Alright, so for the calculation for FH, we use 1 over 2 pi RC for the formula, and then we can get band pass filter for lower cutoff is equal to 318.31 Hz. Same as FL, means F low, we use also 1 over 2 pi RC, and then we get 397.89 Hz. So for the band pass filter upper cutoff is equal to 397.89 Hz.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Nadir Arif, and I will present about our conclusion. To conclude this project, we know an active bandpass filter, the peak of bandpass filter can be much larger than the input voltage signal because of the appearance of amplification, whether it is passive or active. To build a passive bandpass filter, all components required are resistors and capacitors, while active bandpass filters require either transistor or op-amp to provide amplification to the circuit. The bandpass filter are a combination of low-pass and high-pass filter, and how the circuit works is the circuit will pass signal with full strength between the frequencies of the low-pass filter and the high-pass filter. So in our project, the low-pass filter is 318.31 Hz and the high-pass filter is 397.89 Hz. The circuit will output signal between 318.31 Hz and 397.89 Hz with full strength or near full strength. Signals outside of the frequency will be greatly attenuated, so that their amplitude are lesser than the amplitude of signal in the passband. The passband refers to the signal in between the low and high pass filters that are passed with full strength or the near full strength. In this example, the passband is 318.31 Hz until 397.89 Hz. The low cutoff frequency would be 380.31 Hz and the high cutoff frequency would be 397.89 Hz. So frequency outside of the cutoff frequencies are greatly attenuated. And this is how bandpass filter works. Thank you.